Okay, so this is the solution to part 5 of problem 4 of the review tutorial. Okay, the question is, how do your answers to part 4 change if the monopolist third degree price discriminates? So instead of using the first degree price discrimination, we use the third degree price discrimination. So we have to understand first the major difference between the first degree price discrimination and third degree price discrimination. Okay, so let us discuss it. Okay, so in the case of third degree price discrimination, the monopolist is limited to charging per unit prices to each type of consumers. So no two-part tariff is allowed. But the monopolist can check the type of consumers. Okay, this is opposed to the first degree price discrimination, when the monopolist can tell who is what type, can prevent the arbitrage, okay, and is not limited to charging per unit prices. So in charge actually a two-part tariff. Okay, so that's the major difference. Now to maximize the profit, since there are two types of consumers, healthy ones and unhealthy ones, the monopolist will maximize the expected profit. So we have a gamma share proportion of the type 1 consumers. So this is going to be this profit added to 1 minus gamma multiplied by the profit of the type 2 consumers, right? So if you so we maximize with respect to x1 and x2, finding the optimal quantities. Okay, the profit maximizing quantities for the monopolist. We plug in the demand functions, inverse demand functions here. Okay, so this is 20 minus 20 x1 minus 8, and so on for type 2 consumer. Then we simplify and we get this objective function, okay, for the monopolist. Well, the following drill is very familiar to you, or at least must be. Okay, so let's go to the optimization. So first we need to find the first order conditions. Since we're finding the profit maximizing x1 and x2, so we have to take the partial derivative with respect to x1. This is it. So 12 minus 40 x1 is equal to 0, and with respect to x2, 4 minus 20 x2 is set equal to 0. Okay, now don't forget that we need to check the sufficient second order conditions. Okay, so this is taking the second derivative, checking whether they are negative, and indeed they are. Okay, and the cross partial derivatives are equal to 0 here. Okay, so this satisfies this. This is truly the maximum. So these x1 and x2 will maximize the profit. So therefore, we find the from this equation and this equation, we can find the profit maximizing quantities. So x1, I denote by 3d, so the third degree price discrimination is equal to 12 over 40 or 0.3. Okay, so this is 30% of the insurance coverage, and x2 is equal to 4 over 20 or 0.2, or 20% of the insurance coverage. Okay, so we just need to determine the prices that each type consumer will pay. So type 1 consumer pays 14 per unit. Okay, so I'm just plugging in the profit maximizing x1 into the inverse demand function, and I get 14 per unit, and type 2 consumer pays 8 per unit. Now notice that in this case consumers pay higher prices, okay, and these prices are the same that result from the intersection of marginal revenue and marginal cost curves. So if you recall part 2 of this question, we had a similar graph, right? But our price was between 8 here for type 2 consumer and 14 for type 1 consumer. Now, in the third degree price discrimination, we can actually set different prices, right? Okay, to each type of the customer, and these prices are going to be the profit maximizing, as if this monopolist would be selling to these customers separately. Okay, so we have 14 and 8. So this concludes the solution to part 5 of problem 4.